Never trust a machine that says, "I understand." Because back in 1950, one man warned us that maybe they actually might. What if the idea of artificial intelligence didn't start with Silicon Valley, but with a British codebreaker sitting in a quiet room after World War II? In this video, we're diving into Alan Turing's 1950 paper, the one that asked a question way ahead of its time. Can machines think? This isn't just some old academic paper. This is the blueprint for every chatbot, every AI assistant, every smart thing that talks back. And trust me, what's inside this paper will mess with your mind. Let's set the stage. It's 1950. Computers are massive, room-sized monsters filled with wires and vacuum tubes. They can do math, fast, but they can't think. Or at least, that's what most people believed. Then walks an Alan Turing. Turing was no ordinary guy. He cracked Nazi codes during World War II, basically shaving years off the war and saving millions of lives. But when the war ended, he didn't stop thinking. Instead, he started wondering something most people would have found ridiculous at the time. Can machines think? Now that might sound simple, but Turing wasn't interested in surface-level talk. He went deeper. He knew that the real question, can machines think, was too vague. So what did he do? He replaced it with a different question. And that's where the magic begins. Turing proposed what's now called the imitation game. Here's how it works. You have three players. A human, we'll call her Alice, another human, Bob, and a machine, let's say, Siri's great-great-grandfather. Alice is separated from the other two and communicates only through written messages. Her job? Figure out which is a human and which is a machine just by chatting with them. If the machine can fool Alice into thinking it's a human, even some of the time, then Turing says, that machine has passed the test. This test, now called the Turing Test, became one of the most famous ideas in the entire field of artificial intelligence. Why? Because Turing shifted the question from what's going on inside the machine's head to what does the machine do? It wasn't about feelings or consciousness or anything fuzzy. It was about behavior. If it talks like a duck, walks like a duck, you get the idea. Now, this was bold, super bold, because in 1950, even suggesting that a machine could imitate a human mind was seen as borderline science fiction. And don't forget, this was decades before Siri, Alexa, ChatGPT, or anything close. So how did Turing back this up? He didn't just drop a mic and walk away. He tackled every possible argument people might throw at him. Let's look at a few. Objection 1. Machines can't think because they don't have a soul. Turing replies, okay, but do we even know what a soul is? And how would you test for it? He was basically saying, let's not get lost in philosophy when we can measure behavior. Objection 2. Machines can't make mistakes and humans do. Turing, actually, machines can be programmed to make choices. Randomness can be built in. And besides, do we really want mistakes as proof of intelligence? Objection 3. Machines can only do what we tell them to do. Turing, sure, but what if what we tell them to do includes learning, adapting, and making decisions based on data? And that's where things get spooky. Turing predicts learning machines. Not just machines that calculate, but machines that learn from experience. In other words, machine learning. Yeah, in 1950, decades before we even had the tools for that to work. But of course, there's always a catch. Turing knew this idea would face serious pushback, not just from scientists, but from regular people too. Why? Because thinking machines challenge something very personal to us. The idea that we're special. Humans like being the smartest thing in the room. We love that our minds are mysterious and unique. So when someone says, hey, maybe a machine could do what you do, it hits a nerve. And there's another layer to this. Even today, in 2025, we still struggle with Turing's question. Not because we don't have powerful machines, but because we don't have a clear answer to what thinking even is. Think about it. Is a chess computer that beats a world champion thinking? Is an AI that writes poems and songs thinking? Is a chatbot that chats like a human really conscious? Or is it just really good at faking it? And that's the problem Turing spotted way back. He knew that as long as we define thinking in some mysterious, spiritual, or emotional way, we'll never agree. So instead, he said, let's make it simple. If a machine can behave like it's thinking, maybe that's all we need. Let's zoom out a bit. Turing's paper wasn't just about the Turing Test. It was a full-on roadmap for how we might build intelligent machines. He even talked about how to train them. Imagine a child's brain, he said. Simple, flexible, and ready to learn. Now imagine we build a machine like that, not super smart from day one, but ready to be trained. You could reward it when it gets things right, punish when it gets things wrong, and let it improve over time. Sound familiar? That's reinforcement learning. One of the core ideas behind how today's AIs learn to play video games, drive cars, even chat. Turing basically foresaw modern AI in an era when phones still had rotary dials. And he wasn't naive. He even considered limitations. He asked, could a machine ever be creative? Could it have emotions? Could it surprise us? And his answer was, maybe not right now, but in principle, yes. Now here's where things get weird. He predicted that by the year 2000, computers would be able to fool humans about 30% of the time during a 5-minute conversation. And guess what? That's almost exactly what happened in 2014. When a chatbot called Eugene Guzman managed to convince judges it was human, about 33% of the time. Turing didn't just ask the right questions. He nailed the timeline too. And yet, even now, with AIs writing news articles, composing music, and holding conversations, we still ask the same question. Is it really thinking? Here's the punchline. Alan Turing's paper didn't just spark a debate. It opened a door we've never been able to close. It forced us to face the idea that intelligence, real human-like intelligence, might not be exclusive to humans. That maybe one day, machines could be more than tools. They could be minds. It was the beginning of a shift in how we understand ourselves. Because if machines can think, then what makes us so different? That's the question that has haunted computer scientists, philosophers, and regular people for over 70 years. And it all started with a paper called Computing Machinery and Intelligence, just 28 pages long, written by a man who died too soon, but saw the future clearer than anyone else. Turing didn't live to see the AI revolution. He died in 1954, just 4 years after publishing the paper. But his words live on. Every time we say, "Hey Siri," or ask ChatGPT a question, we're playing a version of his imitation game, and we're still trying to figure out who's on the other end. Alan Turing's 1950 paper wasn't just a thought experiment. It was a warning, a guide, and a challenge. He showed us that intelligence isn't just about biology, it's about behavior. And if a machine can act like it's thinking, maybe that's the only test that matters. More than 70 years later, we're still grappling with what he wrote, still wondering if the machines we build are just fancy calculators, or something more. And maybe, just maybe, Turing already knew the answer,